सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Radioactive Community Radio, Bengaluru.
एक नई दुनिया की आवाज आपकी आवाज, विज्ञान की आवाज, की आवाज, की आवाज।
Latest information on STEM popularization.
Indian scientists developed model cosmic dust particles to mimic the unusual polarization of interstellar comet 2I Borisov. State-of-the-art, visually realistic cosmic dust model created by scientists to replicate the unusual polarization properties of the first observed interstellar comet, not gravitationally bound to a star. 2I Borisov can reproduce experimental as well as observational data of light scattered by dust. The particles would be useful to determine the physical properties of dust present in different regions of space. Generally, solar system comets are categorized in two polarimetric classes, low and high polarization comets, depending on different dust to gas ratio observed in the coma. Apart from these two classes, there exists a third class of comets having polarization higher than that of high polarization comets, which was observed only in case of one solar system comet. Such steep polarimetric slope is believed to occur due to the presence of small pristine cosmic dust. Polarimetric studies of 2I Borisov, the first interstellar comet to be observed and studied by the mankind, exhibited an unusually steeper slope, which was observed only in case of one solar system comet. To explain the polarimetric observation of comets, it is important to develop realistic computer modeled dust structures and computationally simulate the scattering of light by such model structures. Recently, scientists from the Indian Institute of Astrophysics, Bangalore, an autonomous institute of the Department of Science and Technology, Government of India, for the first time developed a visually realistic cosmic dust model using a set of numerical algorithms software called REST, Rough Ellipsoidic Structure Tools. Dr. Pritish Haldar, a postdoctoral fellow from IIA Bangalore, working with Professor Srujan Sen Gupta, a scientist at the IIA Bangalore, have crafted surface roughness irregularities from spheres, super ellipsoids and factual aggregates, super ellipsoids and fractal aggregates of spherical grains formed due to coagulation and ballistic agglomeration in the circumstellar or interstellar environment to create the visually realistic cosmic dust particles called agglomerated debris and such fractal aggregates. The RFA structures were authenticated by replicating light scattering response of the circumstellar cosmic dust analogs from the grander Amsterdam light scattering database a database of light scattering parameters obtained from the laboratory, simulation of light scattering over dust samples. Once the numerical light scattering simulation over RFA structures successfully reproduced the experimental results, a dust model was prepared considering a mixture of RFA structure and solid particles over a wide range of sizes from few hundreds of nanometers to few micrometers. Having material composition of amorphous silicate to few micrometers, having material composition of amorphous silicate, forsterite, and amorphous carbon, respectively. The best fit polarization and the best fit polarimetric spectral gradient results were observed for 80% RFA particles and 20% solids, indicating the presence of a huge population of highly pronous pristine cosmic dust particles. The model results also indicate the observed dust to gas ratio is directly proportional to the porous to compact ratio of the model dust structures. The research have been accepted for publication in the Astrophysical Journal, which is published by the American Astronomical Society.
Now, our next segment is Analyst in STEM.
Today, we are with Professor Pratap Vishnoi, Assistant Professor, New Chemistry Unit and International Center for Material Science, Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru.
Could you please brief about the area of research that you're currently working on?
We are the synthetic inorganic chemists, so we develop materials, new materials which respond to magnetic field and temperature. Such materials are often called ferromagnet or antiferromagnet, depending on how they respond. We also develop materials which are called semiconductor, and at the moment there is a huge interest in semiconductor material which absorbs light of various wavelengths, including solar cells. Many of material that we use have potential for data storage, heat storage, as well as capturing sunlight and converting sunlight into other form of light, for example, electric current. And also, many of the materials that we develop, most of them that we target are called halide perovskite, which is the family of materials which have so much current and interest across globe. In various other fields, we explore few of the applications, but there are many other applications. People explore them.
Could you add on about any examples of your research discovery?
Real example?
Yeah.
So we recently developed one materials which is called two-dimensional perovskite, and also a three-dimensional perovskite, which is a molybdenum based materials, which is a metal, and which is magnetically active, and it also has something called frustration. It's a lattice frustration in the crystal, and that leads to the very interesting phenomenon called a magnetic frustration, and is used for it has the potential to be used for quantum computing. With the upcoming technology. It might take some years to reach to common man.
So how was your research beneficial to a common man or India as a whole? And what kind of contribution is it making to the field of science in India?
I'm not very sure common man how it's going to benefit, but many of the material that we develop and we have plans to develop we believe will lead in advancing the technology, particularly semiconductor and also the quantum computing technology, which are the latter one which I mentioned is for the high speed computers.
So what are the hardships that you face in accordance with your research?
Well, there are many things. Failures, we develop new materials. So there are instances where we fail to make the material, we design and then we fail to make that. And then we change the strategy to achieve those materials. So that's one of the the direction on which we feel hardship.
The
It
hardships.
include any kind of hardship in the research, right?
Yeah.
Yes, other thing of being the institute like JNC, let me mention,
Okay.
juggling so many balls at the time, teaching, and there
Yeah.
are other responsibilities, and analyzing results, writing them, sending for publications, and so these are the things basically keep us very, very busy.
Could you brief about your past, present, and future area of research?
All right. So I started my research with PhD in 2008 IIT Bombay, and my research during PhD was largely focused on materials which absorbs lights, including sunlight, and then it emits.
Okay.
This kind of material called a luminescent material.
Okay.
And where we use this material was very interesting. It was used for, and we ourselves explored that area, to sense explosives. Like just for example, trinitrotoluene is one, which is a high energy explosive. Other one is the picric acid. And the moment you add your sensor material, add to these explosives, it's the photoluminescent glow goes off. So you see at that moment there is the explosive vapor is there around.
Yeah.
So it was used largely for sensing. Then after PhD, I did postdoc here, as I mentioned earlier, in the JNC. There I made several materials which are nanomaterials and used for breaking water, which is H2O, into hydrogen and oxygen. And not to mention, hydrogen is very high demand fuel at this moment because it has high energy density, plus it's a clean burning. There's no pollution. Yeah, so that's where I worked here, and then I moved on the area which I'm my group exploring now is the semiconductor magnetic materials, and we'll continue to work in this area some next many years.
Okay. So where do you see your research going in the future?
Yeah, I think it's largely will have some contribution to new technologies, and of course it also has to do a lot with understanding of the fundamental chemistry that these materials include, because when we make materials, there's a chemistry that works behind, and we need to understand that. So the material which we target, many of the chemistries of many of those materials not understood so far.
Okay.
So I think it will generate a lot of scholarly knowledge and plus several technological applications.
Okay. Do you have any idea about where India is right now ranked at in your field of research?
Not exactly hard to rank, but I think it is probably within 10. And there are countries like United States and China and Japan. They are far ahead of us. Essentially, to rival them, or at least to be equal to them in research, we need more research activities in this exciting area, more funding in the research, and more researchers to work.
So could you give some information about your contemporaries? It would be really helpful.
Major contemporaries being the United States and China, the countries in Europe like Germany and Japan. So these are the countries where a lot of work is being done. One of the areas that often also being seen in use is the solar cells, where the part of these materials are being used for the solar cell. And those solar cells are actually, their efficiencies are as good as what you see the silicon solar cell today. So maybe hopeful in some years, the silicon solar cell probably be replaced by the halide perovskite based solar cell.
So how are Indian industries associating with your research project?
So my group is new here. It's about a few months, more than 2 years old. As of now, we don't have industry association, but as we go along, I think when we have materials which are quite potential in the technology, so we feel that we'll be able to have industrial association, particularly in the case of the material which are semiconductor, and also the material that absorbs heat. So these material, what they do, the semiconductor, as I mentioned, you expose to sunlight, it absorbs sunlight and convert that sunlight into current. So the energy conversion and the input energies, is it's not that we are spending. It's a sunlight, so it's it's always available. And heat storage material, I feel, will be more exciting. You store heat and carry that heat anywhere, and then there are ways through which you can trigger material to release the heat for phase change material. So I think in these materials there is they have potential to be associated with the industry in near future.
Okay. So what do you think that India should do in advancing, in accordance with the advancement in your research field?
India should encourage more researchers to conduct research in such materials or the related materials which have potential to be useful in technology. And I think there should be strong connection between the people working in academic, so that needs to be strengthened. So which we lack, and we don't have strong connection with the industries. There are various reasons for that, but that has to be strengthened.
Here we are, signing off. Stay tuned with us to catch up on the latest science updates and learn about STEM experts